Oftentimes in chemistry, and even in everyday life, you will want to dilute something. Well, what does it mean to dilute? Well, dilute means to decrease the concentration of a solution by adding solvent. Decrease the concentration of a solution by adding solvent. And, well, why does this work? Well, in our molarity formula, moles solute over liters of solution, if we add liters of solution by increasing the solvent, we're not adding any solute. So let's say we had a fraction, maybe 1/2, and I change the bottom number to a 4, we go from 0.5 down to 0.25. We've decreased the value of that fraction. The same thing is true here. Because this is a fraction, if we increase the bottom amount, the amount of solvent, we actually decrease the total value of the fraction. At home, you might use a dilution maybe to make a juice less sweet. So maybe you have apple juice and you want to give it to a younger sibling. You'll add water to it so the child will get less sugar in the amount of juice that they drink. In chemistry, we use dilutions when we have a stock solution. So let's say we have a big bottle of hydrochloric acid, and the concentration of this bottle, the stock solution, what we get from the store, the chemical supply company, is 12 molar. That's really strong. That's very, very concentrated. But in the lab that we want to do, we need a solution that is 2 molar. How do we make this solution? Well, we rely on the fact that when we transfer solution from one container to the other, we transfer a certain number of moles, a certain number of molecules of the solute from one container to the other. If we look at molarity as moles over liters, if we multiply that by liters, we end up with how many moles are in the solution. This gives us a very useful equation. The molarity of one solution times its volume will equal the molarity of the diluted solution times its volume. To see how this works, let's do an example. And in this case, the 2 molar solution that we want to make here, let's say we need 3 liters of that solution. I want to know how many liters of a 12 molar hydrochloric acid stock solution are needed in order to make 3 liters of a 2 molar hydrochloric acid solution. So like all of the problems we've done, I want to make a list of variables. We have M1, V1 equals, and then M2, V2. So I need to define these variables. Well, let's see. We have a 12 molar hydrochloric acid stock solution. That's a molarity. So I'm going to call it M1. This is solution 1, the 12 molar stock solution. I don't know the volume. They don't give me a volume for that solution, so V1 will be question mark. The molarity of the solution we're looking for is 2 molar. So M2, the molarity of the diluted solution, is 2 molar. And the volume of that solution that we want to make is 3 liters. So when we plug these values in, we get 12 times V1 equals 2 times 3. So we get 12 times V1 equals 6. So V1 equals 0.5 liters. What this means is we need to transfer 0.5 liters of the 12 molar solution. So let's say this is the 0.5 liters, and the rest of the 3 liters for that solution will be water. So then on top of that, we're going to add 2.5 liters of water. So the dilution equation allows us to figure out how many liters of solution we need to transfer from high concentration to make a lower concentration solution. Let's look at one more example. So here we have 20 milliliters of water are added to 30 milliliters of a 4 molar sodium chloride solution. What is the molarity of the resulting solution? So one clue that we're diluting is that they give us 2 volumes. Another clue in a different type of problem, maybe they give you 2 molarities. And whenever you see that, you need to go to the equation M1V1 equals M2V2. And let's see what we have. 20 milliliters of water are added to 30 milliliters of a 4 molar solution. These two numbers go together, the 30 milliliters of a 4 molar solution. So let's call these M1 and V1. M1 is 4 molar, V1 equals 30 milliliters. We now need to find M2 and V2. Well, the question is asking for the second molarity, so we don't know the value of M2, but we do know its volume. We have to be careful here, though. We're saying 20 milliliters of water are added to 30 milliliters. So what is the volume of the final solution? Well, it's not 20 milliliters. It's 20 plus 30 to give us 50 milliliters. One thing that we haven't talked about for these problems yet before we solve this are units. The molarity M must be in molarity, moles per liter. The volume can be in liters or milliliters as long as both volumes have the same unit. So as long as V1 and V2 are in the same unit, you're allowed to keep it in milliliters. You do not have to convert to liters. So let's solve this, and we get 4 times its volume 30 equals, we don't know M2, but times its volume 50. And when we solve for M2, the molarity of the new solution is 2.4 molar. So when we dilute our original 4 molar solution with 20 milliliters of water, we get 50 milliliters of a 2.4 molar solution.